Section 4.4, congruence and transformations. Essential question, what conjectures can you make about a figure reflected in two lines? First definition, congruent figures. Congruent figures have the same size and shape. So your side lengths, your angles, everything is going to be the same size. A congruence transformation, also known as a rigid motion, is a transformation that creates congruent figures. So example 1 asks us to identify any congruent figures in the coordinate plane. So we're looking for our shapes that are the same. So if we look here, we have EFGH as a rectangle, and down here VSTU is congruent to that. You want to watch out how you match up your sides. EF and HG are the same, so that gives you some flexibility, but VS is the longer part there, so that matches up with EF. FG is the shorter part, that matches up with ST. So as you're going around, you want to make sure those match up. If we look at our triangles, I have KLJ, and that matches with QRP, and KL here, the length of that matches QR. RP matches with the length of LI, and PQ matches with the length of IK. So that's how I match it up. And then ABCD matches with MNOP. And as we see on some of those, they can be turned or rotated or reflected or translated. Okay, so all of those are, and we'll see this later, are known as congruence transformations. Example 2 says describe a congruence transformation that maps triangle PQR to triangle STU. So I'm looking at those two triangles and how do they match up. Okay. So you need to put some thought in this and look at what happens. Right? They're not facing the same way, so it's not just a translation. It's either a reflection or a rotation. If it was a reflection, it would match up, like the R would match up down here with the T. This would be flipped if it was a reflection this way. Reflection this way would be pointing the other way. So that leads us to think it's a rotation. So if I rotate 180, I end up here. And then we slide it down. So you go down, you rotate 180, and then you translate it down 5. Okay. And we look at, I listed the points here for PQR and STU. So we can see that our X value changed is negative, right? But our Y values don't match up. So the 180 would get these being negative, but would also have these negative. So then I move that down 5, and those are all 5 apart. Example 3 says determine whether the polygons with the given vertices are congruent. All right, use transformations to explain your reasoning. So I'm looking to see if these match up. So first thing I did is graph these out. So give me A, B, C, and D, E, F. I graph those. Okay, my lines look like the same, and it's a right across X. So that is a reflection across X. Then we have another definition there, two reflections. The composition of two reflections results in either a translation or a rotation. So I reflect across two lines. It either is a translation or I can figure it out to be a rotation, one of the two. So we're going to look at both instances. So the first, reflections in parallel lines theorem, says if lines K and M are parallel, then a reflection in K followed by a reflection in M is the same as a translation. Okay. So this says if A double prime is the image of A, then I know these two different things. So here, the picture is a little confusing. This is my original line here. This is, then it's reflected across this line, and this is my first reflection. Then I reflect it across this line, and this is my second reflection. And if you notice, these two look exactly the same. I could just slide this over. Okay, so A to A double prime, which is me connecting those two lines, is perpendicular to both K and M. And A double prime equals 2D, where D is the distance between our two parallel lines. So the distance from A to A double prime is twice the distance of this. So we look at example 4. They have this, now they took out the line with D in there, all right, but we have these three lines, and each one is, this is my original. The second one is created by reflecting over this, and then reflecting over this. So a translation maps UV onto which segment? Translation will match UV on the U double prime, V double prime. Which lines are perpendicular to UU double prime? Which would be the line I would get if I would connect those two. That would be lines K and M. Why is V double prime the image of V? And you could say it's two reflections. The easier thing to say there is a translation. And if the distance between K and M is 5 inches, what is the length of V double prime? Up here we said that's 2D, so that is then 10. Now we're going to look at reflections, okay, across intersecting lines. So reflections in intersecting lines, if lines K and M intersect at point P, then the reflection in line K followed by a reflection in line M is the same as a rotation about point P. So here I have this line is reflected across K, and I get this line, which is then reflected across M, and I get this line. And that rotation is 2 times the angle in that the two lines that I'm reflecting across make. So that's what this here is saying. The angle of rotation is 2x, where x is the measure of the acute or right angle formed by the lines. So these two lines form an angle. All right, I want to look at the acute angle, if there's an acute and obtuse, and then I double that to get my angle of rotation. So on example 5, what is the angle of rotation that maps A to A double prime? They give me this angle here is 60, so I double that to get 120. Example 6, my lines intersect. I'm reflecting across. My degree is 70, so my angle of rotation is 140. And then our last one, example 7, the distance between line K and M is 1.2 meters, or 1.6 centimeters. So the pre-image is reflected across K, then in line M, describe a single transformation that maps the figure. So I'm reflecting across 2 parallel lines, so it's going to be a translation. And then I'm translating it double the distance, so 3.2 centimeters. And P prime, if I draw that, its relationship with K is that it is perpendicular. Also realize I don't know the distance between these specific things. I know the distance between the total. All right, but the distance here are going to be different, so it's not going to match up with the 1.6. And that is section 4.4.